Hello, good evening to all. Is it audible? Hello. Good evening to all. This is Juhi Miss from Girls Core Learning Center. We are the fastest growing ETA company in GCC. Our main aim is to provide education to all. I hope you are all doing well, is it? Today we are discussing about a new chapter of Grade 12 Organic Chemistry, that is chapter number 8, amines. Okay, in this chapter, before going to the topic, we will discuss about the syllabus of this chapter. The first one is the introduction and the structure of amines, and then the classification and the preparation of amines, and then physical properties and chemical reactions, and then the method of preparation of disonium salt, then the physical properties and chemical reaction, and the last one is importance of disonium salt in the synthesis. Oh, so tell me, what is amines? What is amines? Amines are the derivative of ammonia. That means you know the structure of amine, is it? What is ammonia? That is NH3. NH3 is ammonia. By the replacement of hydrogen atom by alkyl or aryl group, you will get amine. You will get amine. That is RNH2. This is amine. Why we are studying amine? What is the importance of studying amine? Do you know? See, when you have cough, you take cough syrup, acid. For example, Benadryl. What is that? That is an amino group. And another example for this amine is that when you have toothache, you go to dentist. Is it? Amine used in dentistry is Novocaine. Novocaine is a drug that is used in dentistry. Other two biological active compounds like adrenal and ephedrine is used as to increase the blood pressure. And quaternary ammonium salt is used as surfactant. Again, this is an amino group. So, studying amine is very, very important. In this chapter, we are studying about what is amines, what are the preparation and the physical and chemical properties of amines. Okay, then we are discussing about the structure of amine. What is the structure of amine? We already discussed that amine are the derivative of ammonia, is it? So, like ammonia, it is a trivalent. What is this formula of amine? So, this is ammonia, is it? This is ammonia. RNH2 is amine, is it? So, ammonia, there is three hydrogen atom and there is one lone pair of electron on nitrogen atom. That is unshared pair of unshared pair of electron. Like ammonia, amine is also sp3 hybridized and have a geometry pyramidal. And if you consider the examples of triethyl amine, that is CH3 thrice N. Here you can see that the nitrogen containing lone pair, because of this lone pair of electrons, because of the presence of lone pair electrons, the bond angle will be reduced from 109.5 degree to 180 degree, 108 degree, you can see in the figure. So, In the structure of amines, we discussed that amine is sp3 hybridized like ammonia, and the shape is pyramidal. And for example, in triethyl ammonia, trimethyl amine, you can see that the bond angle is reduced to 1.5 degree to 108 degree. Next, we are moving to the classification of amines. Amines can be classified into amines, amines, amines can be classified into primary amine, secondary amine, tertiary amine. This is the first classification of amine based on the number of hydrogen atoms. Another method of classification is that it may be simple amine, it may be simple amine or mixed amine. It may be simple amine or mixed amine. Another way of classification is that it may be aliphatic, aliphatic or aromatic. So we can discuss the first method of classification, that based on the number of hydrogen atom, we can classify amine as primary, secondary, tertiary. So RNH2. Here you can see that nitrogen contains two hydrogen atom. If the nitrogen atom is attached to two hydrogen atom, you can say it as primary amine. If there is only one hydrogen atom, you can say as secondary amine. Secondary amine. If there is no hydrogen atom, that is R3N, you can say it as tertiary amine. So this is the first method of classification, that based on the number of hydrogen atom, we can classify amine as primary, secondary, tertiary amine. I hope this is clear for you. Next method of classification is that simple amine or complex or mixed amine. What do you mean by simple amine? See, here the R group, this alkyl group is same on either side. You can say it as simple amine. Simple amine. Amine. Suppose if the carbon atom is attached to the nitrogen is different, it will be mixed amine. So CH3N, CH3N, here also there is one hydrogen. C2H5. See here on both sides, there is on one side there is ethyl group and other side there is methyl group. So this is an example for mixed amine. Mixed amine. Next method of classification is that aromatic amine and aliphatic amine. What do you mean by aromatic amine? Benzene ring contain amine group is called aromatic compound. That is, if the benzene ring it is attached to NH2 group. So is it a primary or secondary or tertiary amine? It is a primary amine. Is it? The nitrogen atom contain two hydrogen. So it is a primary amine. This is an example for aromatic amine. Then for aliphatic, you know that CH3, CH2, NH2. This is aliphatic amine. So I hope the classification is clear for you. And next one is we are discussing about the nomenclature of, amines. So, nomenclature of 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 amines. So on each case, the nomenclature is different. For primary amine, the nomenclature will be alkana amine. Alkana amine. If it is a primary amine, the nomenclature will be alkana amine. From alkane, we remove this E and we add amine. We remove the E and we add amine. So its name will be alkanamide. For example, if you consider CH3, CH2, NH2. First, you have to count the number of carbon atom. How many carbon atom? 1, 2. 2 carbon atom. If it is 2, we call it eth. So, ethanamide. The IUPAC naming will be ethanamide. Is it clear for you? Okay. Next example is that CH3, CH2, CH, NH2, CH3. So first you have to find the longest number of carbon atom. So 1, 2, 3, 4. On the second position there is a amine. So the naming will be, if it is a 4 carbon atom, the naming will be bute. Bute, butane, and then you have to indicate the position. On the second position there is an amine group. So butane 2 amine. So this is the naming of primary amine, that is alkanamine. So take your notebook and write the nomenclature for primary amine is alkanamide. For then we are moving to the secondary amine. If it is a secondary amine, the nomenclature will be N-alkyl alkanamide. N-alkyl alkanamide. Write your notebook. Secondary amine is N-alkyl alkanamide. For example, CH3, NH, CH3. See, this is an example for simple amine, is it? So the naming will be N alkyl. Alkyl, instead of alkyl, we write which group is this CH3 group. On the either side, there is same group. So it is called simple amine. So if it is CH3 group, it is called meth. So methyl, methyl. Then this is alkanamide. So N-methyl methanamide. Methanamide. If it is a mixed amine, suppose CH3, NH, CH2, CH2, NH2. Sorry, CH3. So the longest carbon chain is considered as the parent carbon, that is alkylamine part, and the smallest one is alkyl part. So this is the alkyl part, and the longest carbon is considered as the parent chain. Parent chain. So the naming will be N-methyl. How many carbon atom? 3. So N-methyl propanamide. So the IUPAC naming will be N-methyl propanamide. Is it clear? Okay. Another example for this one is CH3, CH2, NH, CH2, 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 CH. So first you have to consider the longest carbon atom as this is the longest carbon atom. This is the chain, parent chain, and this is the alkyl part. Alkyl part. So the naming will be N. How many carbon atom? Two. So it will be N-ethyl. N-ethyl. Then count the number of carbon atom. 1, 2, 3, 4, 5. Is it 1, 2, 3, 4, 5? So it will be pentanamide. So for primary amine, we use alkanamide. For secondary amine, it will be N-alkyl alkanamide. For tertiary amine, we use N-alkyl alkanamide. Okay. We will discuss tertiary amine. If it is tertiary amine, CH3, N, CH3, CH3. See, this is an example for simple amine. Simple amine. So the naming will be the old group is attached is same. So the naming will be N, comma N dialkyl alkanamide. Alkanamide. So the naming will be N comma N. Which group is this? Methyl group. So it will be N comma N dimethyl methanamide. Methanamide. For simple amine, we use N-alkyl alkanamide. Suppose if it is a mixed amine, the naming will be, if it is a mixed amine, the naming will be N-alkyl alkanamide. For example, CH3, N, C2H5, CH2, CH2, CH3. See here you can see the old group is different. Then the naming will be N-alkyl alkanamide. That too you have to write in alphabetical order. According to the alphabetical order, ethyl will become first, then the methyl. Is it? So the name is N-ethyl, N-ethyl, N-methyl, N-ethyl, N-methyl propanamide. Propanamide. Is it clear for you? Then, if it is clear for you, tell me which one is the primary, which one is the secondary, tertiary, classify them as primary, secondary, tertiary amine. So, on the first, you can see that the nitrogen is attached to two hydrogen. So, it will be primary amine. Is it? Here you can see there is no hydrogen atom. Then you can say it is tertiary amine. 3-degree amine. Is it? Here it is NH2. So it is primary amine. And here it is NH. So it is secondary amine. So dear exam, there will be a question like this. Classify them. Which one is the following is primary or primary amine? Or they will be asked which one is the compound is secondary amine, then you can find on the number of hydrogen atom attached to nitrogen. So I hope this is clear for you. The next one is preparation of amines. So you can prepare amines from the reduction of nitro compound, ammonolysis of alkyl halide, the next method. The third one is reduction of nitriles, and the fourth one is reduction of amines. These two are very, very important named reactions in amines, that is Gabriel thiamine synthesis and Hofmann bromamide degradation reaction. When you check the question paper, you can see that these two are important, that in every exam they will be asked, any not only for the board exam, they ask in NEET, JEE, all exams. So study this Gabriel thiamine synthesis and Hofmann bromamide degradation reaction. Okay, the all reactions are important, but you have to give focus on Gabriel thiamine synthesis and Hofmann bromamide degradation reaction. So first one is reduction of nitro compound. So I think you all know that what is nitro group. What is a nitro group? RNO2 is called nitro group. Is it? This nitro group on reduction, you will get amine. Now you know the formula of amine, RCHR Is it? So what you have to study that which reagent we are using here. Which reagent we are using here. So we can reduce the nitro compound either by catalytic hydrogenation or using a strong metal, active metal like tin, iron, etc. So you have to take your book and write the reagents. First one is catalytic hydrogenation, that is adding hydrogen in presence of a catalyst like palladium, either it may be palladium, platinum, or nickel. So H2 bar PD in presence of ethanol. Then active metals such as SN plus HCl or Fe plus HCl. So you have to learn the reagent, what reagent we are using. So suppose if you are reducing nitro group to amine, here we are using H2 bar PD in presence of ethanol, you will get primary amine. If you are using another example for this is CH3NO2. Nitromethane on reduction with SN plus HCl or Fe plus HCl, you will get CH3, sorry, CH3NH2. What is this? This is a primary amine. This is called methanamine. 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 Again, one important question from this part is Fe plus HCl is preferred more. Why? So this is a reasoning type question. Why Fe plus HCl is more preferred? Because Fe plus, when we react with Fe plus HCl, FeCl2 will be formed, and that FeCl2 on hydrolysis you will get HCl again. So initially we have to take a small amount of HCl. That's why only small amount of HCl is required. That's why Fe plus HCl is preferred more. So what in between I'll ask question which reagent are we are using here? Why Fe plus HCl is preferred more? Why Fe plus HCl give FeCl2 Then the FeCl2 on hydrolysis, you will get HCl during the reaction. So only a small amount of HCl is required to initiate that reaction. That's the reason for Fe plus HCl is required. So you have to learn the reagent. This is very important. In conversion part also you need this reagent. So write in your book. Okay. The next one is ammonolysis of alkyl halide. Now you're familiar with lysis. What is lysis? What do you mean by lysis? Breaking. Is it? Breaking. Alkyl halide. The process of CX bond cleavage by ammonia is called ammonolysis. That is RNH3. Ammonia on reacting with alkyl halide, this bond will cleave and you will get using the lone pair. So ammonia here act as a nucleophile. It will attach alkyl part. So you will get RNH3 plus X minus. So what is this? RNH3 X minus. This is ammonia salt. From this ammonium salt, one HX will be eliminated from here. One H and this X will be eliminated as HX. Then you will get RNH2. What is RNH2? RNH2 is primary amine. Primary amine. If you are reacting again with an alkyl halide, again HX will be eliminated. Then you will get secondary amine. RNHR. If you reacting again with alkyl halide, here the HX will be eliminated. You will get tertiary amine. If you are reacting again with alkyl halide, you will get quaternary ammonium salt. So this is tertiary, this is secondary, and this is primary, and this one is quaternary ammonium salt. So ammonolysis is not a good method of preparing primary amine. Why? This is again a reasoning type question. Why ammonolysis is not a good choice for preparing primary amine? Why? The answer is we get a mixture of amine, that is primary amine, secondary amine, tertiary amine, and quaternary ammonium salt will be obtained. That's why it is not a good method of preparation for primary amine. Again, another question is that how will you yield a good how will you yield good yield of primary amine? By taking excess of ammonia, you will get a good yield of primary amine. If you are taking alkyl halide, you will get a mixture of amines. So we have to take excess of ammonia, then we will get primary amine. Okay, so this is clear for you. I hope this is clear for you. So this is a write the chemical equation for the following reaction. Reaction of ethanolic ammonia with chloroethane. So ammonia on reacting with chloroethane. Here HCl will be eliminated. Then you will get C2H5NH2. Again we are adding C2H5 Cl. Again HCl will be removed. We will get secondary amine, that is C2H5 NH C2H5. What is this? This is secondary amine. Here reacting again with C2H5 Cl. Again HCl will be eliminated. You will get tertiary amine, that is C2H5 N C2H5. So this is tertiary amine. Tertiary amine, secondary amine. Again, if you are reacting with chloroethane, you will get quaternary. You will get quaternary ammonia salt. So this type of question also will be asked in your exam. So I hope this is clear for you. In ammonolysis, we get a mixture of primary, secondary, tertiary amine, and that is the disadvantage of ammonolysis. And how can we improve the yield of primary amine? By taking excess of ammonia. Okay. The next one is a reduction of nitriles. So now you're familiar with the nitrile group. Which is the nitrile group? R C triple bond N is the nitrile group. Here also, you know that what the nitrile group will convert it to amine. That is RNH2. Is it? Here also, you have to study the reagent. So, what are the reagent used here? The reagent used here are either you can then the catalytic reduction, or by using lithium aluminium hydride LiAlH4, you can done the reduction, or sodium or mercury in ethanol. You can done the reduction. So not on your book, this is very important. In conversions also you record this one. So here nitriles on reduction with nitriles on reduction with H2 bar nickel, or sodium mercury in ethanol, you will get RCH2. That means reduction means what? Addition of hydrogen or removal of oxygen. Is it? So here the bond will break. Two hydrogen will be added here and two hydrogen will be added here. Then you will get RCH2. RCH2 NH2. You get the primary amine. So I'll write another compound. We have to we have to predict the product. Okay. CH3, CH2, CH2, C triple bond N in presence of lithium aluminium. So we are reducing with lithium aluminium hydride. What will be the product? It will be the bond here. The bond will be break. Add two hydrogen here and two hydrogen here. Then you will get the product. What will be the product? CH3, CH2, 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 NH2. So what is the name? What will be the IUPAC name of this compound? That is a primary amine. The naming of primary amine is alkanamine. So the name will be butanamine. Can you tell me the product of this compound on reduction with on catalytic reduction in presence of nickel? You will get CH2 NH2. Is it? Here also the bond will break. Add hydrogen here and two hydrogen here. You will get CH2 NH. Next one is reduction of amides. So what's the formula, general formula of amides? R C double bond O NH2. Is it? So amides on reduction with lithium aluminium hydrate, you will get RCH2 NH2. Here also add hydrogen here. That is a removal of oxygen, addition of hydrogen. Then tell me the product of propanamide. Propanamide. CH3, CH2, CH2, C double bond O, NH2. On reduction with lithium aluminum hydrate, what will be the product? This group will be changed to a CH2 group. Then it become uh, CH3, CH2, 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 NH2. NH2. So I hope this is clear for you, the reduction of amide. So which reagent we are using here? Lithium aluminum hydrate. The next one is Gabriel thalamide synthesis. Very, very important reaction. What is Gabriel thalamide synthesis? Here, the thalamide on reduction. What is thalamide? What is thalamide? This is thalamide. C double bond O NH. So this is called thalamide. Thalamide. This thalamide on treating with ethanolic KOH. See here, this hydrogen is act as an acid. Why? Because here two electron withdrawing groups are present. That's why this hydrogen act as an acid. So, on acid react with base, what will happen is studied in your 10th standard that when an acid react with base, you will get salt and water. Is it? So here from here, this H and this OH will be eliminated as water molecule, and the nitrogen, this potassium will be attached to the nitrogen. You will get So potassium salt of thiamine will be obtained. Potassium salt of thiamine will be obtained. So this is potassium salt of thiamine. This potassium salt of thiamine on reacting with alkyl halide, you will get N-alkyl thiamine, that is this K and this X will be eliminated as KX and the R will be attached to the nitrogen. So you will get N-alkyl thiamine. You will get N-alkyl thiamine will be obtained. This N-alkyl thiamine on reacting with NaOH. We are taking two molecules of NaOH, okay? NaOH. So from here, this R and this N and this two hydrogen will be eliminated as RNH2. What is RNH2? RNH2 is the primary amine. The main product of Gabriel thiamine synthesis is primary amine, that too aliphatic primary amine. Gabriel thiamine synthesis will respond only to aliphatic amine. So very, very important. Along with that, you will get the side product. And this ONA, this bond will break. This two bond will break. ONA will be added here. So it will become C double bond O, C double bond O, O, Na plus ONA. So, what is Gabriel thiamine synthesis? Once again, Gabriel thiamine. First, the thiamine is reacting with KOH. You will get potassium thiamine. This potassium thiamine on reacting with alkyl halide, you will get N-alkyl thiamine. That thiamine on reacting with NaOH, aqueous solution of NaOH, you will get primary amine. Very, very important. Primary aliphatic amine will be respond to this reaction. Not aromatic primary amine will not give this reaction. Secondary and tertiary amine will not answer for Gabriel thiamine synthesis. Gabriel thiamine synthesis is only used for the preparation of primary aliphatic amine. Why Gabriel thiamine synthesis is not used for aromatic primary amine? That is again a reasoning type question. Why? Because aryl halate do not undergo nucleophilic substitution with the anion formed by thiamine. Is it clear? The next one is Hofmann bromamide degradation reaction. Here the word itself is that bromamide. Bromamide. Amide on reacting with amide here, is it? Amide on reacting with bromine in presence of NaOH, you will get primary amine. So R C double bond O NH2 Br in bromine in presence of NaOH. NaOH. You will get primary amine. Along with that, you will get Na2CO3 plus 2NaBr plus 2H2. So, what is Hofmann bromamide degradation reaction? Here you can see that here initially there is a C double bond O, but on the final product there is no C double bond O. Actually, it degrades the carbonyl compound. So you can study from the word itself. Hofmann bromamide degradation reaction is that amide on reacting with bromine in presence of NaOH, you will get primary amine. And can you tell me the product of this compound CH3 C double bond O NH2 plus Br2 plus 4 NaOH. Write complete the reaction or write the reaction. So by looking at the equation, you understand that this is Hofmann bromamide degradation reaction. The product will be primary amine. On the product side, you will get one carbon atom less than the parent carbon chain. So the product will be CH3 CH3 NH2. If you are taking ethanamide, you will get the product methanamine plus Na2 CO3 plus 2NaBr plus 2H2O. Is it clear? Okay. The next question is write the structure and IUPAC name of the amide which give propanamide by Hofmann bromamide degradation reaction. They give a hint to us that it is a Hofmann bromamide degradation. We have to, the product is propanamine. If you want propanamine as a product, we have to take butanamide as the reagent. What is the reagent? Butanamide. That is CH3, CH2, CH2, C double bond O, NH2. On reacting with what is the reagent of Hofmann bromamide reaction, bromamide degradation reaction? Br2. Is it? Br2 in presence of NaOH. You will get CH3, CH2, CH2, NH2. We get the product. What is the product? Propanamide. What we get? Propanamide. Simple, is it? Along with that, Na2CO3, sodium carbonate plus NaBr plus H2O will be formed. The next question is that amine produced by the Hofmann bromamide degradation is benzenamide. Benzenamide. So what is the IUPAC name of this one? Propanamide. Propanamide. So benzenamide on treating with Hofmann bromamide degradation reaction, what we get? We will see what the product will be. Okay, this is benzenamide, benzene containing C double bond O NH2. Is it? This amide on reacting with Br2 plus 4 NaOH, you will get NH2. What is this? Benzene, or you can say it as aniline. You will get aniline. Along with that, Na2CO3 plus 2NaBr plus 2H2. Is it clear? So these are the method of preparation for amines. So the first method of preparation of amines is the reduction of nitro compound. The second one is the reduction from nitriles. Then we studied about the reduction from reduction of the Then we studied about the method of preparation of Gabriel thalamide synthesis. Then we are discussing about Hoffman bromamide degradation reaction. Hoffman bromamide degradation and Gabriel thalamide synthesis is very, very important. You have to study. Then we discuss about amines, the reduction of amines. Okay. So you have to study the reagent, what reagent we are using. Okay. Then can you comment why ammonolysis is not a good choice of preparation for primary amine? Why? Can you tell me the reason? Because we get a mixture of primary, secondary, tertiary amine. Then, which other reagent we use for the reduction of nitro compound? First one is catalytic reduction, or we can reduce by active metal like iron, tin with HCl. Then tell me why Fe plus HCl is preferred more, because in Fe plus HCl, FeCl2 is formed. That FeCl2 on hydrolysis we get HCl during the reaction. So only a small amount of HCl is required to initiate that reaction. Okay. The next one is physical property. In the physical property, while we are first studying about the physical state of amines. What is the physical state of amines? Lower amines, that is, lower amines are gases with fishy odor. Then, primary amine with 3 or more carbon atoms is behave as liquid, and higher ones, more than above 3, it is behave as solids. So this is the physical state of amine. Then we are discussing about the boiling point of amines. See, amines have higher boiling point than non-polar compounds or comparable molecular mass. Why? So this is again a question, reasoning type question. Why amines have higher boiling point than a non-polar compound of comparable molar mass? Why? Because amines being polar, it will form hydrogen bond, intermolecular hydrogen bond will form. So that is the reason why amines have higher boiling point than non-polar compounds of comparable molecular mass. Okay. The next one is, then if you compare carboxylic acid and alcohol, amines have a lower boiling point. Why? So you know that OH bond is more polar than NH bond. OH bond is more polar than NH bond. That's why amines have lower boiling point than carboxylic acid and alcohol. Okay. So the order will be amines, amines less than alcohol, less than carboxylic acid. So carboxylic acid have higher boiling point when compared to amines. carboxylic acid and alcohol have higher boiling point than amines. So if you consider an the boiling point order of a isomeric amine, that is, if you consider a primary amine, that is CH3, CH2, NH2. Here there is two hydrogen is there. There is hydrogen bonding will be there. If you consider a secondary amine, there is only one hydrogen is there. So the intermolecular hydrogen bonding will be less. If you consider a tertiary amine, that is trimethyl amine, that is CH3, N, CH3, CH3, CH3. There is no hydrogen bonding. So the order will be primary, secondary, tertiary. The order will be primary, secondary, tertiary. Okay. Then can you tell me the order of these compounds? CH3, CH2, CH2, NH2. Then C2H5, OH. Then CH3, CH2, CH2, CH3. Then CH3, CH2, CH2, COH. Write the increasing order of their boiling point. So the first one will be hydrocarbon. This is hydrocarbon. So hydrocarbon has least boiling point. So we will write first that CH3, CH2, CH2, CH3 less than. Then we discuss now that amines have lower boiling point that compared to alcohol and carboxylic acid. So the next one will be amines. Is it CH3, CH2, CH2, NH2. Which one will be the next one? Alcohol. Is it? That is C2H5OH. Then the next one will be CH3. CH2, CH2, COH. Is it? So I'll give another one. Next question is write the increasing order of their boiling point. CH3, CH2, NH, CH2, CH3. Then CH3, CH2, CH2, NH2. The next one is CH3, N, C2H5, then CH3, sorry, C2, CH2, CH2, CH. Write the increasing order of their boiling point. So now we discuss that primary amine increasing order. So the order will be which one has the least? Tertiary amine. Is it? So tertiary amine will come first, then secondary amine. So I will write here CH3 N C2H5 CH2 CH2 CH3 then CH3, CH2, NH, CH2, CH3. Okay. Then the next one will be CH3, CH2, CH2, NH. Is it clear for you? You have to study this order. So write in your book the boiling point order for an isomeric amine is primary greater than secondary greater than tertiary. The next one is the solubility. Like we discussed in aldehyde ketone and carboxylic acid, here amines also lower aliphatic amines are soluble in water. Why? Because they form hydrogen bond with water. Why? They form hydrogen bond with water. If the alkyl part is increasing, they behave as a hydrophobic. So as the alkyl part increases, the solubility will decreases. Higher amines are insoluble in water. So I hope this is clear for you. So I'll give some questions. You have to answer the products. Okay. First, I will write the question. CH3NO2. What is that? This is nitromethane. I am ready. Nitromethane on reduction with catalytic reduction. You will get the product. You will get a product. What will be the product? You have to write that one. So this is the first question. Then the second one is C double bond OCl amide on reduction with LiAlH4. What will be the product? Then amide on reacting with Br2 plus 4NaOH. What is product? So on looking at the first question, you understand that this is a reduction of nitro compound. Is it? The nitro compound will reduce to what? We are discussing about amine. So the product will be an amine group. Is it? What will be the product? You will get. What is this? Can you comment the name of this compound? This is a primary amine. See, from this you can study that it is a primary amine. If it is a primary amine, what will be the IUPAC name? Alkanamine. Then the naming will be methanamine. Is it? So the next one is reduction of amide. That is LiAlH4. You will get here this bond will break. Hydrogen will be added there. Then you will get RCH2 NH2. What is that? That is amide on treating with bromine in presence of NaOH. Which named reaction is this? Which named reaction is this? Hofmann bromamide degradation reaction. So the CO group will be degrade and then you will get the product as R NH2 plus Na2CO3 plus 2NaBr sodium bromide plus what? Is it clear? Okay. Then another question is that phthalimide. So what is the structure of phthalimide? NH is phthalimide. Phthalimide on reacting with KOH. So you will get a product. This product on treating with C2H5Cl, then you will get a product. That product on treating with NaOH, you will get a product. So complete the reaction. So what will be the product here? Here this H and this OH will be eliminated as H2O. Then you will get the product potassium phthalimide will be obtained. Is it? Potassium phthalimide will be obtained. This potassium phthalimide on treating with chloroethane, you will get a product. Here you will get a product. That means this K and this Cl will be eliminated as KCl. C double bond O, C double bond O, N C2H5, N ethyl phthalimide will be obtained. That phthalimide on treating you will get ethanamide will be obtained. C double bond O, ONA, ON plus C2H5 NH2. What is this? This is called ethanamide. Is it clear? The product will be ethanamide. Okay. Why aromatic phthalimide do not undergo aromatic primary aromatic amide do not undergo Gabriel phthalimide synthesis? Why? Because aryl halide do not undergo nucleophilic substitution with the phthalimide with the anion formed by the phthalimide. Okay, so I hope this is clear for you, and you have to study the reagent thoroughly, and the Gabriel and Hofmann bromamide degradation reaction is the named reactions. So you have to write that on a notebook, that the named reactions and what reagent we are using here. Okay, on Wednesday your Satyan sir is coming, so stay tuned with us. Thank you.